Hello everyone, I'm Gongfang.
I'm Aditya.
I'm Yizhi.
We are working on the application of HoloLens in construction industry.
Utility location is the process of identifying and labeling public utility mains that are underground. These mains may include lines for telecommunication, electricity distribution, water mains and wastewater pipes. In some locations, major oil and gas pipelines and rail and road tunnels also compete for space underground. Underground utility lines being struck is a long-standing problem worldwide, causing public service disruptions, project delays, cost overruns, property damage, injuries, and fatalities that cost billions of dollars each year. Utility strikes are attributed to two main causes: the lack of reliable data regarding the true locations of underground utilities and the lack of an effective means to communicate the inherent uncertainties associated with utility location data to end users. Inaccurate utility information leads to falsely instilled confidence and potentially misleads equipment operators into unintentional utility strikes. This project envisages the use of an augmented reality head-mounted device to enable visualization of underground utilities during excavation to prevent such incidents from taking place. HoloLens is leading the way in augmented reality hardware for the modern enterprise, including the construction industry. HoloLens has the ability to relate the internal coordinates of a map or a photo image to the ground system of geographical coordinates. This is particularly helpful in construction projects that use GIS data, as the HoloLens automatically maps the virtual world or image and superimposes it onto the real world location. Underground utility data would be available in the ideal scenario in the form of an ArcGIS, which uses georeferencing to pinpoint accurate locations of pipelines.
Our main work is to offer a solution for how ArcGIS underground utility data can be overlaid into HoloLens. The workflow can be divided into four major parts. First, according to the data provided by the ArcGIS, we can precisely navigate the location of the underground utilities. Second, we build the 3D models in SketchUp based on the ArcGIS map and the related underground utility information. Third, we transform the finished models to Unity and do corresponding modifications to fit for our construction site. Finally, we upload our models to Visual Studio so as to deploy the models onto HoloLens. At the end of the project, our goal is to ensure that the HoloLens can scan the surrounding environment when we enter the construction site and superimpose our models that could be fixed in our construction site accurately. Critical to note that FBX is the format that could be shared with SketchUp and Unity. Visual Studio is the platform that could solve or debug the Unity C# project. Once you finish the above operation, next time the construction manager just needs to carry HoloLens and enter into construction site. Deploying the HoloLens, superimpose the models, and could easily observe the underground utilities for a long time.
Besides, our models can be georeferenced in the real-world scale. Once we get enough underground utility data from ArcGIS, we could create as much models as we want.
After we view our model in the HoloLens, we can pick the model up and place it over the real-world location. Further, if we use HoloLens to show the 3D pipeline model in a real location, it may have great potential to avoid utility breaks while digging and preventing errors when marking line locations on concrete or lawns. Once we place our model into a particular location, the model is fixed here, and whether we turn our head up and down, the model doesn't move and is combined with real-world scenario.
We would like to express our gratitude to our faculty mentors, Professor Sang-Hyo Lee and Professor Vineet Kamath, for their constant guidance, encouragement, and suggestions through the course of our project.